Hi people, welcome to the next lesson on static determinacy. We looked at this one in the previous lesson. We worked to this one quickly. We worked to this one here. I'm just quickly going to talk to this one here. Okay, we're testing the formula. M is equal to 2j minus 3. What's M? The number of members. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. No joint there, so that's 9, 10. Did you get that? There's no joint there. That's why there's no little circle there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore M is 10. Number of joints, 1, 2, 3, 4, 5, 6. So J is 6. So 2 times 6 is 12 minus 3 is 9. So notice here, M is not equal to 2J minus 3, but M is greater than 2J minus 3. And if M is greater than 2J minus 3, it means the truss is hyperstatic. That means it contains a redundant member or two. Okay. Now, I'm not going to do this. You must do this yourself. Okay. Take either that member out or remove that member and do the exercise again and see what you get. Okay. And see if it'll be perfect after that. I'll say it again. Either remove that member, okay, so you make the members 9, or you remove that member and you make the members 9. Okay, do the exercise again and see what the result will be after that. Okay, alright, so I'll leave it up to you. Don't just assume it. Okay, work through it. Remember what I said in the note earlier in the introduction? Work through everything I give you. Okay, don't just say, oh yes I know. Work through everything I give you. Right people, now notice these 4 frames here. We just looked at the frames themselves, and of course the frames are attached to supports. Okay, so we're going to look at frames that's sitting on supports. Okay, and because it's being supported, okay, we need to take those support reactions into account. And when we do that with frames sitting on supports, the formula to use there will be M plus S equal to 2J. Okay, so for the frame without supports, the equation to use to check static determinacy is M is equal to 2J minus 3. If we have a frame sitting on reactions, okay, the formula to use is M plus S is equal to 2J. Right people, I'm taking this frame here and I'm going to apply this formula here, okay, and to check whether it's statically determinate or not. Right, there's the formula, M plus S equal to 2J. Right, so what's M? M is the number of members. M is equal to 1, 2, so it's equal to 2. What's S? S is equal to the number of reactions. Now people, in the text I gave you, this was an error here. Okay, now remember, if you cast your mind back to types of joints, a roller joint has got 1 possible reactions, a pinch joint has 2 possible reactions, and a built-in or fixed joint has 3 possible reactions. Okay, now in this text that I took it from, the author forgot to put in this reaction here. Okay, so S is the number of possible reactions. So if there's a pin, we're going to have 1, 2, 3, 4 reactions. Okay, alright, so, and J is the number of joints, so we got 1, 2, 3. So what's 2 times 3? A 6. And M plus S is equal to 4 plus 2, which is 6. So therefore this side is equal to that side. Okay, so therefore this here is a perfect frame, so therefore this frame is statically determinate. Okay, so that's how we use this formula when we have a frame sitting with reaction. That's the formula we use, and we're using this formula to check if this frame is static determinate. And from that, because the left side is equal to the right side, it's a perfect frame. Right, so let's look at the next example. Right people, there's number F on the page. There's number F there. Okay, number F. Right, what's M? M is the number of joints. Sorry, nonsense. M is the number of members. Okay, notice we've got a frame there, exactly the same, sitting on 2 pin joints, but we have a tie sitting at the bottom there. Okay, so M number of members, 1, 2, 3. S is the number of reactions, because we've got 2 pin joints, we've got 2 possible reactions for each one, so it's 1, 2, 3, 4. Okay. Number of joints is 1, 2, 3, so therefore 2J is equal to 2 times 3, which is 6. Okay, so M plus S is equal to 7, and 2J is 6. So therefore, M plus S is greater than 2J. What does it mean? If that's greater than that over there, that means this frame is hypostatic. It contains 1 or 2 members which we can remove, and when we take it away, it will still make the frame stable. Okay, and what can we do? I think you've noticed, yes. Okay, if I take this member away here, if I remove this member, if I take it away, it's gonna look like this one exactly over that. Okay, and then this frame, this hypostatic frame, will now become a perfect frame. Okay, so once again, if you have a frame sitting on supports with a reaction, that's the formula we use to test for static determinacy. Okay, and if I go back to the document I gave you there, if I look at the previous one, okay, if I quickly just, you can work with yourself. M is equal to 1, 2, 3. S is equal to 1, 2. Right, notice there, we've got a roller joint. And the roller joint goes, a roller joint has 1 possible reaction. So therefore, S is equal to 1, 2, 3. Okay, M plus S is equal to 6. And 2J is equal to 2 times 3, 6. So therefore, M plus S is equal to 2J. Therefore, this frame is a perfect frame. Okay, let's have a look at the next one. I'll quickly work it quickly there. Number of members is 1, 2, 3, 4, 5, 6, 7, 8. That's why it's 8. Number of reactions, because we have 2 pin joints, so it's 2. That's how we get 4 there. And 2J, we've got how many joints? 1, 2, 3, 4, 5, 6. 2 times J is 12. 8 plus 4 is 12. Therefore, this frame is a perfect frame. Okay, so that's how we test for that one, and they're both statically determinate. Okay, this next to here, you can do it yourself. Okay, I'll do this one quickly here. Number of members is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's get 9. Number of, and because we've got two pin joints, we've got 2 possible reactions per joint. That's why that's 4. And of course 2J, how many joints? 1, 2, 3, 4, 5, 6, 7. 2 times 7 is 14. So M plus S is 13 and 2J is 14. So that means the left hand side, if I can just, can I write it there? I don't think so. No, don't know where. So M plus S is less than 2J. So therefore this frame is substatic. So this frame is potentially unstable under load. Okay, right. Do the same with this one here. Okay. Count the number of members, count the number of reactions. Notice there's 4 pin joints, so we've got 8 reactions. Count the number of joints and see, so we can see from this, so check your equation for M plus S equal to 2J and see if you get that that is actually hypostatic. Okay, so check that there. Okay, check that. Right, people, so work through all of that. That's the next lesson, the next lesson on static determinacy. And if I go to if I go to your I put in more frames there very quickly. Let me just dig it out very quickly. I put frames 1, okay, frames 1, frames 3 and frames 4. I'm going to upload it to Blackboard. Work through all those frames there and check whether the frames are statically determinate. Okay, check whether the frame is perfect, check whether the frame is hypostatic, and check whether the frame is substatic. Now, if I open the first one, frames 1, there's it over there. Yippee! Does it look familiar? Yes, it does look familiar. If you've worked through everything I asked you in the apply mechanics, you would have worked through this over there. There's the question, determine the support reaction, determine the size of the force, and whether the force in tension or compression using method of joints. Okay, but what we're going to do, we're going to check whether this frame is static determinant. That means we're going to check whether it's a perfect frame, whether it's hyperstatic or substatic. Okay. Right, people, I brought that frame in there, which is the first one from the document in frames 1, which I'm going to upload to Blackboard very soon. Okay. The question is determine whether that frame is statically determinate. Okay. And because it is sitting on supports there, so which formula we're going to use? We're going to use that one over there. So what we do, we first count the number of members. Okay. So I'm doing it over here. Let me just do this quickly. Right. So M is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now remember, even though we don't show it here, every one of these joints is a pin joint. Okay. And then S is the number of reactions. There we have a pin joint. So pin joint it's got 2 possible reactions. Okay, I'm just going to throw it in like so. We're not concerned with the size of the reactions. We're not concerned whether it's up or down, but we know there's 2 possible reactions. And we have a roller. It's got 1 possible reaction, and it's in the vertical plane because it's free to move this way. So S is equal to 3. 2J. What's J? Number of joints. 1, 2, 3, 4, 5, 6. So 2 times 6 is 12. So M plus S is equal to 12. So therefore M plus S is in fact equal to 2J. So what does it mean? It means our frame is perfect. Okay? And that means this frame is statically determinate. And because it is statically determinate, we can go ahead and solve the frame like we've actually done already at Apply Mechanics. Okay, so people, that is how we solve that one there. So what you do, you go to the next frame and you apply the M plus S equal to 2J formula to this one and to that one, and to see whether it's perfect or whether it's static determinate or statical indeterminate. Okay, right, people, so that you do that there to those frames there. And also if I just go to frames 2, well, that one there, frames 3. Remember, if you did all your work that I asked you to, yes, you would have solved those frames too. So you need to go to those 2 frames and check whether those 2 are also statically determinate. I'm going to put that in Blackboard as well. And I'm going to put frames 4 also on there. You need to check, is it familiar? Yes, it is. It's familiar because you have to do it in Apply Mechanics. You need to apply this formula and check whether that frame and that frame is also statically determinate using the formula there. Okay. People, that ends the lessons on static determinacy. So by the end of this week, you should have worked through all of these exercises and answered those questions. Okay, all the best, and I will see you in the next lesson.